Dot product of two vectors. Vector A acts at an angle theta with another vector B. So theta is the angle between vector A and vector B. Vector A dot vector B equal magnitude of vector A, magnitude of vector B cos theta. Therefore, vector A dot vector B equal AB cos theta. We cannot give dot or cross between AB cos theta. So vector A dot vector B equal AB cos theta. So this is what the expression of dot product or cross scalar product. Dot product is also known as scalar product of two vectors, vector A and vector B. Vector A and vector B, where theta is the angle between vector A and vector B. Now, in the expression of vector A dot B, AB cos theta, A is scalar, B is scalar, and cos theta is scalar. Hence, we can say that dot product between two vectors, dot product of two vectors produces scalar quantity, a scalar quantity. If, and also this dot product follows commutative law. Commutative law. Hence, therefore, vector A dot B will be equal to vector B dot A. This is commutative law. That means dot product of two vectors follows commutative law. Vector A dot B equal vector B dot A. Now we can consider that vector A acts at an angle 90 degree with vector B. This angle is 90 degree, theta equal 90 degree. We are considering two mutually perpendicular vectors. If vector A perpendicular vector B, comma, then that is if theta equal 90 degree, then what will be the expression of dot product between two vectors, vector A and vector B? Vector A, vector B will be equal AB cos theta. AB cos theta means AB cos 90 degree. Therefore, we can say that vector A dot vector B equals 0, since cos 90 degree is 0. In reverse way, if vector A dot vector B is 0, then vector A will be perpendicular to vector B. Now we can move to the next page. We can consider three-dimensional axis. I cap is along x axis, j cap is along y axis, and k cap is along z axis. I cap, j cap, and k cap are the unit vectors. I cap, j cap, k cap are the unit vectors along x, y, and z axis respectively. So if we find I cap dot I cap, that will be equal to mod I cap cos 0 degree. Mod I cap is 1, mod I cap is 1, and cos 0 degree is also 1. Hence we get I cap dot I cap equal 1. I cap is a unit vector, that's why magnitude of mod I cap, magnitude of I cap or mod I cap is also 1. That means dot product between similar type of unit vectors is unity or 1. ICAP is 1. Similarly, jcap means dot product between unit vectors along y-axis, that is jcap will be 1. Again, kcap is also 1. jcap is 1 and kcap is also 1. Kcap is the unit vector along z-axis. Now we can find the value of dot product between two orthogonal unit vectors ICAP. ICAP is along x-axis and jcap is along y-axis. ICAP equal mod jcap cos 90 degree, because y-axis is perpendicular to x-axis and this angle is 90 degree. Mod ICAP is 1, mod jcap is 1 and cos 90 degree is 0. That's why ICAP.jcap will be 0. Mod ICAP is 1, mod jcap is 1, but cos 90 degree is 0. Similarly, we can find ICAP.ICAP will be 0 and jcap.jcap is also 0. As dot product produces scalar quantity, that's why ICAP.jcap will be 0, not 0 vector. We can express vector A in terms of rectangular components of that vector. Vector A equal AX I cap plus AY J cap plus AZ K cap, where AX, AY, AZ are the rectangular components of vector A along X, Y and Z axis. Vector B equal VX I cap plus BY J cap plus VZ K cap. BZ K cap. Now we can find the dot product where AX, AY, AY, AZ and BX, BY, BZ are the rectangular components of vector A and vector B respectively along x, y and z axis. Therefore, vector A dot vector B is equal, we can put the expression of vector A, AX I cap plus AY J cap plus AZ K cap, bracket close, dot, bracket open, BX I cap plus BY J cap plus BZ K cap. BZ K cap. Now we can multiply AX I cap with the three terms of vector A, vector B. So if we multiply AX I cap with BX I cap, then that will become AX BX I cap dot I cap under bracket plus AX BY bracket opened I cap dot J cap bracket closed plus AX BZ bracket open I cap dot K cap bracket closed. Now we can multiply AY J cap with the three terms of vector B. That means AY BX under bracket J cap dot I cap bracket closed. AY BY bracket open J cap dot J cap bracket closed plus AY BZ bracket opened K cap dot K cap. Now we can multiply AZ J cap dot K cap, AY BZ J cap dot K cap. Now AZ BZ K cap dot I cap plus AZ BY K cap dot J cap plus AZ BZ K cap dot K cap. K cap dot K cap. There are nine terms. Due to dot product between vector A and vector B, we get 9 terms. AX B, and now I cap dot K cap, J cap dot I cap, J cap dot J cap, and J cap dot K cap, K cap dot I cap, K cap dot J cap, and K cap dot K cap. Now we can move to the next page. Equal Therefore, vector A dot vector B, continuation of the last page, Ax Bx under bracket I cap dot I cap plus next two terms will be 0 plus 0 plus Ay By J cap dot J cap. The next three terms will be 0, 0 plus 0 plus 0 plus 0. Then what final term will be Az Vz bracket opened K cap dot K cap. So I cap dot I cap is 1. That's why you can write Ax Bx plus Ay By plus Az Bz, because J cap dot J cap is 1 and K cap dot K cap on the ninth term will be again 1. Since we can write I cap dot I cap is 1, J cap dot J cap is 1 and K cap dot K cap is also 1. But if we consider I cap dot J cap or I cap dot K cap, I cap dot K cap will be 0, I cap dot K cap will be again 0. So finally we get vector A dot vector B as Ax Bx plus Ay By plus Az Bz. So this is the formula of dot product of two vectors in terms of their rectangular components Ax Bx, Ay By and Az Bz. So dot product of two vectors is what sum of product of same type of rectangular components of two vector. Also vector A dot B is magnitude of vector A, magnitude of vector B cos theta, where mod vector A equal root over ax square plus ay square plus az square. Mod vector B and mod vector B equal root over bx square plus by square plus bz square. Now we can consider few examples of dot product. Examples of dot product. Number 1, W equal vector F dot vector S. So W is the work done. In this diagram we can denote force vector and displacement vector. This is displacement vector, and along this direction force vector acts. Theta is angle between the force vector and displacement vector. This is the work done. This is the work done by a force vector F. Force vector F, where vector S is the displacement vector. Vector S is the displacement vector which occurs at an angle theta with the direction of force vector F, which acts at an angle theta with the direction of force vector F. Number 2, P equal vector F dot vector V. P means the power. This is the expression of instantaneous power when a force vector acts on a body and body moves with instantaneous velocity v. Here vector v is the instantaneous velocity, instantaneous velocity vector. Third one is phi e equal vector e dot vector a. Which is electric flux, that is the number of electric field lines, passing through an area normally, area vector A normally. Now we can explain by drawing a diagram. This is an area which exists in xy plane area, and an area vector acts perpendicular to the plane of the area. So area vector acts along z axis and area exists in xy plane. Electric field intensity vector E acts at an angle theta with the area vector and at an angle 90 degree minus theta with the plane of the area. Here vector E is the electric field intensity, that is field intensity vector, that is force vector experienced by unit positive charge, that is +1 charge. Number 4 example is phi b equal vector b dot vector a. Phi b equal vector b dot vector a, which is magnetic flux, that is the number of magnetic field lines, passing through an area vector a normally, area vector a normally. Also for electric flux, we have to consider the number of field lines passing through an area normally. Where vector B is the magnetic field induction, that is field induction vector, that is force experienced by unit north pole. Magnetic field induction is actually the force experienced by unit north pole.